Example number 19. Consider the following table of values of the functions f and g and their derivatives at various points. Part A, find the derivative with respect to x of f of g of x at x equals 3. Part B, find the derivative with respect to x of g of f of x at x equals 4. So first, a reminder of what you do to take the derivative when you have a composite function. The first thing you do is you take the derivative of the outer function and multiply that times the derivative of the inner function. This part is the chain rule. And if you do it in the reverse order, the process is the same. You do the derivative of the outer function first, and then multiply that times the derivative of the inner function. That is also the chain rule. In this case, we don't know the function, but we know some values. So to find our first derivative with respect to x, we're going to have to start on the inside. So it's going to be f prime of g of 3 times g prime of 3. Now I can't find f prime of g of 3 until I find g of 3. So it's going to be f prime, and I'll go to my chart, and I'll find g, and I'll find 3, and I see that that is 4. So it's going to be f prime of 4 times g prime of 3. So in my chart, now I'm going to look for f prime of 4. F prime of 4 is -1 times g prime of 3, which is 7/9. So -1 times 7/9 is -7/9. That is the answer for part A. So now part B. The first thing I'm going to have to do, starting on the inside, I can't find g prime until I know what f of 4 is. Then I'll multiply it times f prime of 4. So I go to my chart. So then I'll have g prime, and I have to find f of 4, which happens to be 4 this time. And then I'll multiply that times f prime of 4. So I go back to my chart. I find g prime of 4 is 1/9 times f prime of 4 is -1, and I multiply 1/9 times -1, and I get -1/9. So the first answer was -7/9, and the second answer is -1/9.